Welcome to KennyRoy.com. I'm Kenny Roy. This is the lecture for 2011, month of January, and it is on constraints for animators. Now, why am I doing an entire lecture on constraints? Reason is that they are a very misunderstood, underused tool that are, or can be, an essential part of getting the performance you want. Everything I try to show on the site comes back to performance. I give tips sometimes that seem like they're cheating, but they're not. There's no way you can have anything that helps you get to closer to the performance that you have in mind that could be called cheating. So for instance, in the pantomime lecture, I gave the tip, I also give it in the workflow lecture for using inner monologue as your timing tool for pantomime. And if you feel like it, record a track, like a dialogue track of that inner monologue, and use it as the audio track for your scene file. No reason that could be called cheating. No way. Why? Because if you can get the poses you want and then time them with that performance choice you have in your head, then that's just you being a good performer. That's you being a good actor. So there's no reason, there's no like pride reason or ego reason that animators should think that this should all inherently be really hard to protect the way, what we do or our jobs or anything like that. If it's easy, then the best performers will be the best animators, and that's the way it should be. So this as well, this is kind of like that inner monologue as a timing tool tip, in that I want this to be something that gets you closer to good performance, and constraints are underused, and they are very powerful, and they can do a lot of really awesome things. Okay, so it's very important that you get that kind of familiarity with constraints, that they're just completely just, no worry about them, no problems with them. You're never like trying to figure out like, wait, what did I do wrong here? Anything like that. You're just using them the way that they were meant to be used, and everything is going, everything is just going swimmingly for you in your scenes. That's what I want for everybody, is just be having a blast with your scenes and just performing through the computer as a tool. Okay, so my goal is for this to be the last constraint tutorial you ever watch, ever, because I want to cover everything there is to know about constraints. We're going to fly through the basics of constraints, which you probably all already know, because you can't avoid using constraints pretty much in animation. But then I want to get into some things that maybe you're not doing with constraints, and show you a few ways, a few times that I've actually done some things with constraints that have some pretty cool implications for my rigs and for my scenes and stuff like that. So let's see here. We'll start with the basics. First, what is a constraint? You probably know this, but a constraint is a way to lock the transforms of one object to another. Okay? A way to lock the transforms. What transforms are, at least in Maya, there is a transform node and a shape node, and normally those are combined together to make an object. Okay? So a group, for instance, is a transform node without a shape node. So if you want to think about transforms as groups, then that's a good way to think about them. It's a node that has position, rotation, and scale data on top of it, and that's it. It's that simple. Now, when we talk about locking the channels of one object to another, we're talking about actually creating a connection, but it's different than using the connection editor or setting up a simple expression, because there are no mathematical equations going on. There's no multiplication or division or anything like that. It's not something that is like a driven key as well, because a driven key, you can have sort of you can actually adjust the curve of a driven key in the graph editor. I mean, driven keys are very powerful. It's not that. So we should also, in learning how to use constraints to their fullest extent, we should know what it is and what it isn't. Okay? A constraint can be just positional data. It can be just the translate XYZ channels, and that's called a point constraint. It can be rotational data. That is just the rotation XYZ channels. That's called an orient constraint. And then it can be a scaling relationship, and that's just called the scale constraint. Easy enough. And then there's a last constraint. There's aim as well. We're not going to talk really about aim because that's really not going to be something that you're going to use really for performance or helping yourself out with performance. But that aim is basically locking the orientation of one object to be pointing at the pivot of another. But there's a last constraint that is the most used, and it combines positional and rotational data in one. It's called the parent constraint, and we're going to spend most of our time talking about the parent constraint. Okay? You should note that the parent constraint is not a true parent-child relationship, because scale transforms are not in this constraint. So if you wanted a true parent-child relationship where even the object is scaled within the parent object's object space, then you would have to add a parent, and then a scale constraint. And that's very common, actually, especially when you're setting up rigs to use a scale constraint. If you're adding stuff to rigs, I'm frequently using rigs and then just adding a ponytail or something like that, and rather than search through where it needs to go in the hierarchy and add all sorts of offset groups and stuff like that, sometimes I just throw a scale constraint on there. I'll show you a couple things that kind of relate to that. You can choose which channels are constrained. 1 channel, 2 channel, 3 channels. You can pick which ones you want to be constrained. So that can create a whole lot of interesting setups with your scenes. You hopefully by the end of this lecture, you're going to find, hey, you know what, this scene would have been easier to animate if I had just constrained 1 channel or something like that. So we'll see. Okay, you can turn it on and off. Unlike parenting, unlike putting a group under as a child of another object, constraints can be temporary. So a constraint node has a weight parameter that you can dial up or down or anything in between, and you can even add more than 1 constraint and blend between the 2 constraints. So that's one reason why they're extremely powerful and fantastic. And I've done plenty of things where an object needed to be basically blended in a constraint setup, and I'll show you how to do that as well. So let's just dive into it right away. Okay. So what is a constraint? Let's just start there again. We're always going to use the sphere as the object that is constrained, and the terminology is we're going to constrain X to Y. So constrain the ball to the cube. Okay? Constrain this to this. And the order you choose it in is obviously the parent first, and it gives you this little tool tip. All right? So if you hover over it down here at the bottom, it says select one or more targets followed by the object to constrain. So you can actually add a constraint with more than 1 object at a time. And then what ends up happening is it sets up a relationship where the child object is actually equally weighted between 2 other objects. But we're not going to look at that just yet. We're just going to work with one thing at a time. So let's start with the parent constraint. because the point and orient are basically combined make the parent constraint, and you can figure out what you need to do with those after this. So I'm just going to constrain the ball to the cube, and you select it in the reverse order of the way you say it, and just click parent. Okay. Now if we look at both the ball and the cube, you'll notice that the cube doesn't have this as an input, but it does have in its attribute editor in the list of nodes attached to this the parent constraint as well. One thing to start doing is start naming your constraints. Okay, if you're not going to animate the constraint, it's okay to not name it. But for the purposes, as we go along here, you're going to see that it's going to be a good idea to name your constraints and name them for what purpose they're going to serve. Okay, so for instance, if you were having a character holding a sword, you would say sword to hand constraint instead of like, you know, polysphere1 underscore parent constraint 1. That doesn't tell you any information. Where this will help you is when you're turning constraints on and off and on and off. So if he puts the sword down and then he picks it back up and puts it down, picks it up, you're going to want to know which constraint you need to use to do that. Okay. Another thing that's nice to do is to create a little indicator right at where the constraint was made, and I'll show you why we're doing that in a second. So since I left the sphere at world origin, I can create a locator. Okay, and here's the locator. It's a little hard to see. See, there it is. Okay, and rename that locator again to be the positional. So what I would call this, let's say like ball underscore to sphere, or sorry, to cube. And then I do say something like constraint POS, constraint position. Right? You need to spell it correctly. Okay. And then constrain the locator as well. Here's why. If we end up moving the ball, okay, you can move the ball, but once you either frame advance and move the parent object again, or frame advance and try to set a key, what you'll notice is that even if you set a key, oops, I gotta turn blend parent on. Even if you set a key on the object itself, it doesn't matter. See, I have these two keys. Here's one over here. It doesn't matter. If you advance the frame with keyframes on the object, it always snaps back. Okay. Now, why does it snap back? Because the first thing that you need to understand is that what you can animate, what you can change, is the strength of the connection, but never the position of the connection. It creates a lock, right? But that lock basically is not a lock like a chain. It's a lock like a rubber band or glue, like gum, like stretchy gum. So if you want to change the position of the constraint, you're out of luck because it's only the strength of the connection that you can change. All right, so let me show you, let me go back and show you what was going on here, okay? Most people get tripped up here. This is where most problems happen. People are trying to, they animate this box around, and then they're like, okay, well now the box needs to drop off this sphere right here, and then they start animating this and moving it around and setting all these keys, and it's like, oh, well that sounds good. Oops, blend parent. Got to make sure that that's one. And I'll demonstrate what the difference is there. And then all of a sudden, again, So I'm going to set a key here, set a key over here, and then set a key up here. And when I go back to those keys, nothing happens again. Same problem again. So this is where most people get tripped up. Okay. Now the difference is, let me set a key again. And what you notice is by default, right when you add a constraint, it adds this channel called blend parent. Now here's the difference between the blend parent channel and the weight channel in the parent constraint itself. The blend parent channel is the channel that you use when you want to turn all of the constraints off. And it's the one that you animate if you want to release the hold of the constraint on the object itself. Basically what it is, it's the strength of the glue that is holding the object in place. Okay? And the weights are also kind of the strength of the glue, but they're only going to be as strong as that blend parent channel is, if that makes any sense. It's basically, this is the distribution of the weight in the overall constraint setup. So if you had 10 objects here and they were all, they all had a weight of 1, then all 10 objects would have equal governance over the object that is constrained, whereas the blend parent is how you basically animate a constraint on or off. See, because if let's say we key this object right here and we key the weight, and then we dial the weight down to 0, and then we key this again, set key, and then we try to move it over here, you'll notice that even though there's no weight on that constraint, because blend parent is still at 1, we've got a problem. So what we'll do is we'll go to the same frame and we'll animate blend parent down to 0, and then you'll notice that the object is free to move. Now let's set a key right here and then go 5 frames forward and then animate blend parent back up. Look what happens. It sucks it back to the position of the constraint. This is why we created a locator at the position of the constraint. Now let me move this object out of the way so you can actually see where the locator is. It's not on the world origin axis. Okay? And then we'll see again. All of a sudden, we have clear as day, this is where the position of the constraint is. And this is why we created that locator. So you know, if you're sitting, animating this around, do-de-do-de-do-de-do, where is it going to go back to? And it's nice to just have that there. Okay, so this constraint setup is, everyone pretty much knows how to do this. This is great and fine and whatever. But what if you want to move this object as well as have it constrained to this box? Okay. Well, then you probably need to do a little bit of work to make sure that the transforms are not going to be locked. So what I'm going to do is I'm just going to delete all these keys, okay, and I'm going to move this back to where the constraint is, and then I'm going to group it, Control-G groups, all right, and now we have this underneath a group. Remember, a group is just a transform node without a shape node, so a group is an object as well, except there's no geometry there, okay. Now, if I want to move this object around, all I have to do is just make sure that I'm going to center these pivots as well and freeze transformations. Okay. All I have to make sure is that the transforms are not locked. And how you do that? Again, you just make a group and then you constrain to the group. Or you constrain the group to the cube. So here's the cube. I'm going to grab the group as well. I'm going to hit parent. And now what's interesting is I'm just going to move this cube down to here. And because there's a constraint set up, all right, they move together. But I also get to grab this sphere, which is just riding around in this group that's constrained. And I can move it wherever the heck I please. And you'll notice that it's still actually moving with the group as a whole. All right? So that's great as well, because that's a really easy way for us to get our objects to be freely movable in a constraint situation. And if you know anything about rigging, you know that this is a very common setup. However, we normally don't want to be moving objects around themselves. So what are we going to do? All right, well, let's just pretend that this cube is a control. In fact, I'm going to make it a control. There's a really awesome script called KK Controllers. KK_controllers on creativecrash.com. You should check it out. This is KK Controllers. It's free to download, and the thing I like about it is that with one click, you can create a controller on the pivot of any selected object. So I'm just going to delete this object and return this to the origin, freeze transforms, and then I'm just going to put this kind of like right here, okay, in freeze transforms. All right, so now I have this controller, okay, which is a NURBS curve. Normally all controllers are curves. I'm going to put this curve in a control group. I'm going to put this sphere, it's already in a group, I'm going to call this the geo group. And now I'm going to create a joint, and I'm going to skin this. All right. So obviously, since it's created with one bone or one joint, the joint has 100% weight on the whole sphere. So this is now our joint. Now we're going to call this joint group. And now I'm going to grab all three of these groups, and I'm going to group it, and I'm going to call this sphere rig. And this is totally, totally normal to have a control that you parent and scale constrain the joint to, and then the geo just rides the joint around. And this is beginning to look like a character rig, isn't it? You have your control, it moves the geo, and you can scale it, move it around, whatever. All of a sudden, we're starting to, look at what we have. We're getting into rigging now. So where does this take us? Let's start talking about how to use constraints properly with rigs, because now it looks like we have a rig set up. Let me call this sphere rig real quick. Okay, so I'm going to do these demonstrations with Bloke. There's no reason I'm using Bloke over any other rig, only pretty much because he's free and you guys can get him if you want. Let's talk about constraining an object to a rig. Okay, let's say we're going to have Bloke toss a ball. Oops. Okay, we're going to, again, because we don't want the object itself to be constrained or to be moved with this setup, we're going to make sure that there's one level of control above the object that's being constrained. So I'm going to create just this little controller using KK controllers on the ball, and then here it is. It's just a little spherical kind of NURBS curve setup. I'm going to parent the ball underneath the NURBS curve, and then you're going to grab the controller, grab the curve, and then hit parent constraint. I already have the window up right here. Parent. Okay. Now, if we move this object, the ball is constrained. Now, pretty simple, right? This will get you through 90% of your constraint situations, because normally you guys are doing stuff where the character is holding something. Now let's make Bloke toss the ball. So he's going to anticipate it down just a little bit, and then he's going to toss it up. And let's also key this, just a little bit of overlap. maybe one more frame of overlap, and he's really gonna flick his wrist here, okay? So now we have him tossing the ball like so, and the ball's still connected. Here's where people also get tripped up. Remember, you're not actually changing, let me hit set key and make sure this blend parent is at 1. You're not actually changing the position of the constraint when you are when you're animating the constraint itself. You're only animating the strength of the constraint. Okay, so you're always going to come up with situations where the object is not exactly where you need it to be. So with this situation, I would say that probably this is the last key, that the hand would be totally kind of determining the position of the ball. It would probably be a little bit free in the next frame. So I'm going to set a key, and then in the next frame, I'm going to turn off the blend parent. Now we know what we need to do because we've animated bouncing balls all the time. We're going to key it back into position. Okay, and then over, I don't know, let's say 10 frames, or sorry, what is that, 6 frames? Let's do 8 frames up, 8 frames down. Okay, now we can go into our graph editor, our translate Y curve. We can make it, you know, nice and plateaued if we like, which we do. And let's make this curve weighted and just free the weights and make this a little bit more plateaued. Okay? Then at this frame, we need the hand to catch the ball as well. Actually, you know what? Let's make this 2 frames later. Now let's make it 1 frame later and actually a little bit further down. Let's not have him catch it in the same place that he threw it. Now we need to animate the hand back to catch the ball. And I'd say that's pretty good. If you've seen the contact lecture, you know that we never animate the instant of contact. So you'll see that the ball and the hand are actually not quite touching. In fact, it probably should be a little bit less. Okay? So they're not quite touching. Most students also get tripped up right here because you're thinking to yourself like, oh man, I need to get it exactly where it needs to be or it's not going to look right. Actually, it's the contrary. If you animate that instant of contact, you're going to be probably calling too much attention to it, and you're going to actually kind of display your process marks. So you don't want to show off your process marks by, again, having like the hand, having there be a frame where the hand is exactly, you know, just like microscopically touching the ball. Okay, so here we are, the hand is about to catch the ball, and then we need to be concerned first and foremost with how the arm is going to animate, not the ball. So let's actually animate the hand catching this weight naturally. So the arm will probably only go down about that much and then come back up. But the hand itself is going to probably really bend like that. I'm going to assume that this is kind of a heavy ball. Okay, so the hand is moving a lot quicker, just like that. Now remember, this is the frame that we want this to happen on. So on this frame, we just set a key. On the next frame, we dial that blend parent totally up, and then we have the correct situation where the what do you call it? The sphere is actually the frame before it's not touching, and then the frame after it's touching, and both objects have moved. Now here's kind of the deal. You'll see that it kind of rotated. The sphere itself kind of rotated. So this is when you have a true rig like this with a control over the object you want to animate, you can then go in, set a key on the sphere itself, and then kind of animate it a little bit back into position. Okay, so you'll see that it kind of looked like it was going to go straight down, and then it kind of moved a little bit to the screen left. That's okay, because we can move it back here. So that's probably too far. Yeah, like that. All right, so here we go. Now we have our constraint set up perfectly. Okay, so this works for us in 90% of situations. You have your object, you need to, if it's an object that you've created in the scene and not a rig you've created yourself, then you need to put it at least under a group. Normally I actually put the sphere itself under an offset group. All right, you just group the sphere. All right, in fact, this will work even if you do this later. So I just grouped it and it still works, and you can animate this group. It's also common to have more than one offset group. So if you have a little bit of animation on this group and you need to tweak it in some other section of the scene, you can group this again. Now we have two groups over the sphere, and you can put animation on this, and you'll notice that the animation still works with this setup. Okay, so this all works. It's all great. It's all lovely. Okay. So what about if you need to constrain an object to two hands? The best setup to have is a single controller that controls the left hand, the right hand, and the object, and all three of those have an offset above them. Reason you want to do that is because when you're working, you want to make sure that it is super simple to keep all those objects together. You don't want to be fooling around with counter animating or animating on ones or doing any sort of like weird cleanup that is going to take a really long time. So let me show you the way that I would do that. Okay. So let's have a bloke holding whatever this is going to represent. Let's call this a coffee can. Okay, let's just create a simple controller around it. It's kind of cool. This is like sort of like a little cylinder controller here. All right, let's just size it to our object a little bit. Okay, let's freeze transforms on this. Okay, so here is our object itself. Remember, we want this to have an offset, so we're just going to call this, for now we're going to call it cylinder offset. Okay, then we're going to parent constraint this controller that represents that connection. We're going to parent the controller to this, or sorry, the offset to this. All right, so now it's moving around. Okay. So we're just going to position these hands on the geometry itself, okay? But remember, we need to have a little bit of control over the hands still. So how are we going to do that? We're going to create an offset, but we're going to create an offset with a parent constraint. All right, so this is how we're going to do that. Let me make a interesting shape controller so that you can see what's going on. All right, here's this weird sort of spiky ball controller, okay, and I'm going to make another one on this hand, okay. I'm going to make on this controller a offset group, and this one as well. So now we have a group. Now both of these controllers are in a group, and this controller is going to be the object that is constraining each hand, not the main cylinder object. Why are we doing that? You'll see in a second. G repeats last command. I'm not sure if you know that, the letter G. So if you just made a constraint, you can do another one by selecting the right objects in the right order and then hitting G, and then you're done again. Okay. Now I'm going to select the cylinder again, and I'm going to constrain the groups, the offset groups. Now what we have is the object moving around, the geometry moving around that represents the paint can, and both hands. All right, and so you just need to animate this nice, and with nice arcs and whatever, and everything will be fine. Now, let's say you want to have the hands slide around. Because we constrain the group above this hand, we can still. I'm just going to set a key right here. I'm going to drag it up like this, okay, and I'm going to key this right here, and tip it over like this. Okay, so now you see that the hand moves up the side. Let's make it a little bit more dramatic. Let's have it start underneath here. Okay. Now you see the hand moves all the way up where I keyed it, even though it's still within this group. Now we do this because it's much easier to have a single control kind of representing that entire relationship, but we also need those offset groups because if you're trying to animate, let's say you're animating a character holding a bat and they're, you want them to go like this. You want the overall motion governed by that single control, but you also want them to be able to, really dig in with their grip right there. Right? So that's why this is extremely important. Okay? So I'm going to save this as well for you guys to watch, or for you guys to have. Okay? Now let's talk about constraining a hand to an object. That is normally the other kind of relationships that you have, right? Because if you are having a character climb a ladder, if you're having a character hold on to something, whatever, you have this situation, right? So again, I'm going to make these IK. Okay, so let's say that Bloke is driving. Okay, I'm going to make him a little bit of a steering wheel. Here it is. Again, the way we want this to work is kind of like we just did with two objects. With one object, we constrain the object to the hand. With two hands on one object, we constrain the hands to the object. Okay? So this is kind of the same thing in reverse. I'm going to create like this interesting controller right here, and this is going to have a group, and then this steering wheel is going to constrain to the group. But before we do that, let's actually position it. Let's get that pull vector down here. This hand control, let's actually have it gripping. Kind of cool. Now this is a very, very common use for constraints, and by that I mean when you want an object to actually drive the motion of another. So now we have this steering wheel, and it would be impossible to have the hand stay completely put, like animating it on a perfectly spherical or circular arc, right? So you just want it to be do-do-do-do-do, right? While at the same time, if you want the hand to be able to, move just a little bit or slide around just a little bit and make it a little bit more natural, you can totally do that as well. Okay, so this is a very, very, very normal setup that you would want to have. Okay, now, again, let's talk about animating this connection. Okay, the hand obviously would never be able to move on a nice circular arc if it wasn't for this constraint, but you don't need that for the entire shot. Let's just pretend you don't need that for the entire shot. I want to try something right here, actually. All right, it just snapped I want to talk about maintain offset before I talk about this other issue real quick. Okay, interesting. All right, let me try this as well. Oops. All right, what maintain offset is, maintain offset just means that it's not going to actually copy the values. It's not going to be a connection. So if the object you're constraining or the parent object has like a translation of 1, it with maintain offset off, it's going to make all the transforms match that parent's transform. So everything is copied exactly. So that's why it snaps to a position. You do want that sometimes. Normally when you're using point constraints, you do want that, and that's when you're rigging, and we can talk about that later. But for all others, you normally want to maintain offset because you positioned the hand, for instance, on the steering wheel, and the steering wheel has different transforms than the hand does. So you need to maintain that offset distance so that they can move around together, but this one doesn't have to be right where that one is, right? I'm just seeing something here. Yeah, interesting. All right, I was just testing something. Okay, so again, we're just going to create the parent constraint. Now, when you want the hand to come off the wheel, what are you going to do? You're going to need to animate the constraint. So now I have a key. The wheel is rotating up to here. Then I have the blend parent animating down to 0, and then I have the hand coming off. Now, if I take this object and I rotate it back down, and then I animate the blend parent back up, it's going to go down to this new position. In fact, this is kind of hard to see, so what I'm going to do is I'm actually just going to extrude a face here so you can see. Okay, so here's the position. So when the hand comes off, that's great, but then the object rotates and the hand goes back down to where it was. So what do you do? If you want, again, you can use this control to animate the hand back to where you want it to be on the wheel itself, because you did create this as an offset controller, or you can make a new constraint. One thing you might actually notice is that constraints or FK-IK switches are actually constraints. Basically what you have is like two rigs, one that is the FK rig and one is at the IK rig, and the FK-IK switch is actually a constraint blending between those two rigs. So you might actually have noticed that's what goes on. Because when you animate it, it looks a heck of a lot like what happens when you're animating the strength of a rig anyway, or strength of a constraint anyway. So let's just take a real quick look at that and see what's up with that. Hey, what's up with that? Okay. So here we go. Let's say we have our FK elbow bent like this, and then we we dial up the IK. See how it goes back to the IK? There it is. Now it's a good idea. They have to, when they make these rigs, have a little bit of a cutoff point where the controls for one system disappear and the controls for the other appear. I like to actually constrain a controller or constrain a locator. We can do whatever. To the IK control, constrain parent. okay? So that when I am blending around, I know that where the controller is going to be. So if I move this character around, I know where I need to key my FK hand in order for it to blend nicely into the IK. So I'm going to put it somewhere like right here. And then I'm going to animate the FK-IK switch. Also need to animate the elbow down. And then I can just put it back into position. See, now we have a nice blend between the FK and the IK because I knew exactly where it was going to be. So this is an interesting situation. I've done this actually a few times already. I've had to basically create a hierarchy change using constraints. The idea was the character was holding on to something above their head that was moving around. All right. So let's say it's a ball. So what I did was I had the character holding on to the ball, basically by using the IK arms. Okay. Does Bloke stretch? Awesome. Awesome. All right. And what I wanted was a nice fleshy kind of, pendulum effect on the entire body. Now again, you don't have to have everything be super hard. Why does it have to be hard? We don't get anything out of it for the process being really, really hard to do. Right? It's just harder and nobody wins. So what I did was I created some controls. Why are these all so big? I guess Bloke is a really small rig or something. Okay. I'm just going to freeze transform this and copy it. And then what I did was I determined what the different points excuse me, of the rig I wanted to be basically a new almost FK chain. All right, you'll see what I mean in a second. Basically, this sphere was driving all this movement around. So he's holding on to this crazy sphere that's moving all around, okay? So this controller, I'm going to constrain. I'm not going to do the offsets just yet because the offsets are not going to come in handy just yet. Then what I'm going to do is I'm going to constrain the geometry to each one of these controllers. But first, I'm going to make a simple FK chain with these controllers. Basically, I'm going to change the pivot of these controllers to the controller above. Nothing needs to be too perfect. I'm not just saying that because I'm being lazy right now. Really, these should be time-saving tools. So if you want it to be perfect, you probably actually spend more time than you should on it. Then I'm going to constrain the main controllers that I want to move. Let's see here, okay. Main controllers that I want to move to this new chain. But first, I'm actually going to parent these to each other. So now I've got a simple FK chain. If you see, I rotate all three of these. See, it bends like this. Then I can constrain the controllers that I want to move with these new controls by using a simple parent constraint. I did, when I was working on the scene that I'm talking about, I did use offsets on the controls on the body. You also want to as well, so that you can have like the legs spread or something. Okay, actually, you know what? I'm just going to do that really quick because it doesn't take really any more time. So I'm just going to create a locator. And the locator is holding on to this foot. And the locator is in a group, and then the new FK controller is going to constrain that group. And then this other foot, we don't care. We're just going to do one for speed here. Now, what I had, in effect, was this ball that I could whip over here, okay, and whip, you know, to the right like this, and then let's just have it come back. And what was cool was that this new basically FK rig that I put on the whole body was controlling the entire character in almost a new, a completely new way. And there's no reason that I can't have him let go and just animate normally like he would as a normal character. And now remember, I put an offset group on this one, so the cool thing about that is I can actually have, you know, a little bit of kind of cool custom animation on any body part that I put an offset on. All right, and let's see here. I want a little bit more bend down here. Looks like the head follows this. Let me just turn this off. Don't actually know how to turn that off. Head follow. Anyway. Yeah, well, we'd have to figure out how to change that, but it doesn't quite matter for our purposes right now. So then I had this character being whipped around by this one object, and there you go. You have basically your own hierarchical changes that you made on the fly, and it made your animation so much easier to do. Can you imagine how hard it would be to do this scene if you had a character that didn't have this system on top of it? You would have to animate, you know, everything on this, you know, implied arc, and everything would have to be kind of, you know, eyeballed and all that stuff. It's just so much easier to really use the power of constraints to make the character work how you want it to. Okay. Now, sometimes you get into trouble because your little custom system here doesn't work with like the render rig if you're working at like a studio or something like that. This is what I would do if I were you. Keep your animation scene like this, but then bake channels on your controls when you're done. So the way you bake channels, the fastest way is to select all the controls that are constrained. Okay. And go into the graph editor, and then go to curves, and then bake channel, and then just bake the entire time slider by 1. And what you'll notice is that the animation values get copied onto the curves. Here they are. And then you can actually delete all the constraints. Like for instance, let me just delete this constraint, for example. Just deleted it. Let's delete this one for good measure. Okay. Let's delete the hands. Okay. And you'll notice it still actually works. In fact, the connection is basically broken between the controls and the rig. So now you have nice, clean. Well, I mean, it's on ones, so it'd be hard to edit this animation. But you keep your little custom rig, and nobody has to know about it. All right, everyone's going to be asking like, "Wow, how'd you get him to really like whip around like he's? How'd you do that with the rig?" Only you will know. Okay, so this is great if a character is like flying around as well, because you're going to be animating your character off of the layout control, and the layout control is the only one that really has the control to move all of those controllers underneath it as well. And normally there's enough offsets and groups underneath the layout control that you can make it so you can do some animation on the character as well, right? Great. So if you're animating him off of the layout, however, sometimes becomes a pain in the butt. Where is it? There we go. So you move him off the layout. Let me just key everything right here. Oops. All objects off. There. So this would be a pain in the butt to make him fly, because if you rotate this down, look how, like how are you going to have him like go exactly where you want him to go with all this crazy rotation? Again, all you need to do is, let's say he ducks down and then is about to fly like this. Boom, you just create a control where you want him to be, moved from here. Here it is. And then you constrain the layout to this new control, set a key, and then whoosh, here we go. Now we have detailed control, where we need it, and off he goes. See that? So you guys are going to get this as well, so you can look at it. Okay? Call this flying. All right. So another thing you can do. I've worked with some rigs that were knuckle walkers, so it needed to be an IK rig. However, the pivot of the hand needed to be on knuckles. So again, all you have to do is, knowing how the constraint is set up, is make a new pivot on the knuckles. Now this one, actually no, this one is at the wrist. I was mistaken. Okay. So why can't you just move the pivot itself? Because the control is parent constrained to the bone, or the bone is parent constrained to the control anyway. Meaning, if you try to move the pivot, what you're going to do is you're actually going to be moving the constraint itself, because the constraint is to the pivot of the object. So what I would just do is create a new control, okay, right here, position it at the knuckles like this, and then parent constrain the hand control to this new, and now look, you've got a pivot on the knuckles, so this character can, basically, roll around on his knuckles as much as you possibly want. Okay? So if you're swapping out rigs constantly, you want to make sure that you're using the bake animation on those constraints to make sure your animation conforms to the rig that you're given. You may run into trouble if you have nested constraints. Okay, and a lot of nested groups, and especially like your own basically custom FK system on top of the rig. Okay, so baking is a good way to fix problems as well. I've had a lot of experience with rigs that don't cycle correctly. One issue with cycling is that you need to make sure that your foot controls, or any IK control in the world, but normally the problem is with feet, have Z pointing perfectly forward, meaning that you're going to be moving your feet forward in Z alone as the only cycle with offset channel. Why? Because you don't want to have to counter animate any translation in a different channel to have the character walk forward. So what I've actually done is on rigs where the feet were pointed slightly outwards, and I had to rotate them in order to have them move forward, was I just created controls on the feet, okay, that were basically, you rotate the feet in and then create a new control that is zeroed, and that the foot straight is now the controller's forward in Z, and no other channels move it forward, okay? And then after you animate that controller as the Z controller on that foot in the parent constraint setup, you grab the foot when you're done, you bake animation on all channels, and you'll see all the the rotation, the little bit of X value actually growing and growing and growing. But at least you'll get a perfect cycle that actually will cycle with that setup. It won't be just hacked together or eyeballed or anything like that. So it's a way to fix rig problems as well. If you needed a character to be knuckle walking around, then that's one way. That's one thing you can do. Or if you have a problem with walk cycles or anything like that. Okay, so I hope you got a little bit out of this. Remember, let's go all the way back to the beginning, the basics of constraint. A constraint is basically a way to lock the channels of one object to another. It can be position, rotation, or scale, or it can be position and rotation at the same time. It's called a parent constraint. You normally, under most circumstances, want to maintain offset. It's one of the checkboxes in the parent constraint options box. And constraint is one way. It is temporary because you can change the weight, and you can actually constrain an object to more than one object, and the way that the weight is set up will be how much it is either moving with one object or the other. If you are constraining an object to a rig, you normally want that object to be in a group, and you want to constrain the group instead so that you can move the object underneath. It's much better if you have a little bit of a rig system with every single object that you have, at least a controller. Or if you don't want to make a controller a group. But a controller is nice just because you get a little bit of extra visual feedback as to where that constraint is happening. If you're constraining the rig to an object, you want to create a little bit of an offset there, but the way that rigs work is that normally there's not an offset group above the controls that you can constrain to. So you need to actually constrain the let's say it's the hand to a new controller, and then that new controller is underneath the group, and that group is constrained to the new object, like we saw with the steering wheel. And then finally, constraints are great for fixing rig problems, creating your own hierarchies if you want to do some interesting animation. If you want to constrain the entire rig to something, you can, and that's a great way to have a character like riding a dragon, or tumbling down like a building that's falling over or something like that. You can always use the layout control, and then just make sure you make a new control at the current pivot of the hips that you want to use, and then voila, you have basically a new layout control wherever you need it. So hopefully you got all you need from this lecture to never have a problem with constraints again. I hope that this lecture spawns some discussion, and you can, if you're having problems recreating or using the scene files that I am going to upload with this lecture, that you will post it in the forums and ask each other questions. I want you guys to be talking and to be helping each other out. One more time, I know you've heard this story a few times, but I learned pretty much everything I know technically about CG from forums. It was a long process because I wasn't extremely I wasn't dedicated 24/7 to it. So, you know, using a forum can be even more powerful than an experience than it was for me. But again, everything I know, I learned from my fellow, you know, my fellow 3D artists from forums. So I want the forum to be a powerful resource for you guys as well. So that's basically it. Thank you for watching this lecture. The Ask Video mails are going well. Also, please send your Ask Video mail questions to webmaster@kennyroy.com, and please suggest new lecture topic ideas in the forums. There is a resource wish list that you can use, and you can just post your idea and then have other people comment on it. I have a few in there that I'm trying to gather comments on, and then maybe you can pitch in your opinion on whether or not you think it would be a good experience or a good lecture for you guys to have. So that will do it. Thank you for watching, and as always, rock on.